Alright. So, area between two curves. Really nothing too new about this. Just go through logically with you here. If I want to know this area between those two curves, and let's say this was our function f of x, and this was our function g of x, it is as simple as you probably think. Okay? If I found the area from A to B underneath f of x dx, that would give me all this area here, right? All the way down to the x-axis. I don't want all of it, okay? So all you're going to have to do is what?
Subtract.
Subtract the area under the curve from A to B of g of x dx. It is that easy, okay?
You make it sound so simple, but it's not.
So the answer would, or the way to solve this would simply be f of x minus g of x dx from A to B. Okay? Notice I put the extra bracket around there so I didn't have to write it twice. You have to take the function that is further up and subtract the one that's further below to find the difference between them there. Okay? If you did it the other way around, you'd get the opposite of what the answer would be. Okay? But this is the general idea as to what we're doing. So it's really nothing too new.
But if you get a negative answer, you should know it, though. You should never get a negative answer for this.
Sure you could. If the entire area is below the x-axis,
Oh,
you could
yeah.
get a negative answer. Or there's more area below the x-axis than there is above.
Oh, yeah.
Okay? Alright, so in general this makes sense?
Well, big, yeah.
Okay, we're going to do some examples. Find the area of the region, of the region bounded by y equals x squared plus 2, y equals negative x equals 0, and x equals 1.
So would the 0 and 1 be from like our 0 to 1? That's what we're...
And we probably won't even finish this problem. I'll just ask you to write out the antiderivative that would help you solve this problem. Okay? Some of you should be able to visualize this without too much of a problem. Some of you will want to draw the graphs to help you. Okay? If you think about this, y equals x squared plus 2, that graph would look something like this. It's a parabola that's been shifted up 2 units from the origin. Y equals negative x. That's a line with a negative 1 slope. X equals 0 is a vertical line right here. X equals 1 is another vertical line right here. So the region that is bounded by those four functions would have been that area, that region right there.
What happens if the line would have crossed? Or they would have crossed somewhere?
You would probably need to set up a couple different intervals. Okay. So, to set this up, alright, we want to find the area between the curves from 0 to 1. Those are my x values, and I want to find the area. So, the area from 0 to 1. Now, this function is the function that is further up in the y direction. So that one's going to come first. Alright? So that's going to be your x squared plus 2 minus the one that's further below. So that's your negative x. If on a test, all I asked was for the setup to help you find the area under the curve, this is what I would want to see. Okay? And there will be some tests where all I ask for is the setup. You don't actually have to finish it. Okay? So all you have to do is show me this. Okay? Alright? Now, let's go ahead just to finish this one so you can actually get a response though to it. Okay? The antiderivative, do we need to do anything special? Just each individual term should work. So?
1/3 x to the cube, or
Plus 2x.
and then it's a plus 1/2 x.
From 0 to 1, right? Antiderivative of x squared would be 1/3 x cubed. Antiderivative of 2 would be 2x. This is really plus x back here. So the antiderivative of plus x would be plus 1/2 x squared. Okay? How do we finish this?
Plug in 1.
Plug in a 1, get that answer. Minus, plug in a 0, get that answer.
Which would be 0.
Subtract it. Okay? Plug in a 1 is pretty easy here. This would be 1/3 plus 2, so I'm up to 2 1/3 plus 1/2, so now I'm at 2 5/6. Okay? Which would be 15/6. That's what I got by plugging in a 1. What do you get when you plug in a 0? 0. Final answer is 15/6 units squared. Okay? You alright with that? It's 17/6, doesn't it?
Yeah, that's what I'm saying.
So, especially when you do it on camera. How often do you have to deal with negative areas? He said like,
So it's only negative as a whole thing.
If the entire shaded region was below the x-axis, your answer would come up negative.
is that the only time where you can have a negative area in math?
Yes. I mean, it's not going to represent anything realistic.
It's just weird to think about negative areas.
It would be a little more realistic if you were talking, you know, a distance with direction in a sense. Like physics going backwards.
It's like prior mother, or you do reverse mother. This kid's bowl cut.
Alright, another one here with you. Find the area between
I've already done that.
F of x equals 2 minus x squared, and g of x equals x.
But you know,
No, just the area between those two. All right. So thoughts?
You draw it out.
Yeah, definitely draw it out. Okay. F of x equals 2 minus x squared. What does that look like?
So it's basically x squared minus 2, so negative x squared.
Upside down parabola.
And then down, yeah,
That's been shifted
up to.
up to units. Okay. I'll try and be a little more particular here on this one. Okay. So there's 2 minus x squared, and then g of x equals x.
It's pretty good to me. Straight line.
Yeah, definitely.
Find the area between those two curves. After drawing it out, the area between these two curves would be this region right there, correct?
Oh.
That is the only region that is bounded by those two curves.
I got you now.
Because
Wouldn't that be considered between two curves though too?
over here,
Yeah.
but it's unbounded.
It's endless.
It would be infinite.
Okay.
Same thing. So just the finite region, in a sense. The region that's bounded on all sides, enclosed.
There you go. So we're only gonna find areas of bounded.
Yes. Yep, for now.
About it.
Okay? How will this one need to be set up?
Easy.
Guys, how will this one need to be set up?
We're gonna go from. We have to find out where it crosses.
We've got to find out where they intersect, don't we?
Yeah.
I drew a pretty good graph from negative 2 to 1 because that was the x value
Oh, that's pretty good.
where they hit. 1 is the y value where they hit.
That's pretty good to me.
So if you draw a good graph, you can tell where they are intersecting. Okay? Another way to do it is you could just set the two functions equal to one another and solve for x to see where they equal one another. To find the x values where they equal one another, so you won't even have to draw a picture. So if you just want to know where does this function meet this one, well, when does 2 minus x squared equal x? Well, 2 minus x squared would equal x when 0 is equal to x squared plus x minus 2. I moved everything over to the right side. I would factor it. X plus 2, x minus 1. Or in other words, x equals negative 2 and x equals positive 1. Those would be the x values where those two graphs meet. So then my setup would be, okay, I want to find the area between the curves from negative 2 to 1. That's where I found out where those two functions intersected one another. And then which one has to come first?
The
The f of x, the 2 minus x squared. That one is further up. And we want to subtract then the area of g of x from that. So 2 minus x squared minus x dx. So this would be our setup to help us find the area of that region that is bounded by those two curves. I'm not going to solve this one for time purposes. I feel like you guys know how to do that. Okay? But if I ask for the setup, guys, I'm going to be picky. You need that bracket around the entire thing with the dx on the back side of it. Okay? You need to write it out correctly with good notation. If you don't put that bracket, then it looks like it just, that part has the dx with it. Okay? Or if you put dx outside of both parentheses, that will be fine too. Okay? Questions on that one?
I don't know.
Any questions on that one?